Hello and welcome. Today we're going to dive into an exciting little Python project where we'll build our own version control system, similar to Git, but simplified. We're going to use only standard built-in Python library modules, and the purpose will be to help us deepen our understanding of file manipulation, hashing, and data storage in Python. So let's get started. First, let's set up our project. I have my terminal open and we'll create a directory. We'll call it VCS, and then we'll go into that directory. And then we'll create just one file. We'll call it vcs.py, our Python file that'll contain all of our logic. And then we're going to use Visual Studio Code here to do all of our work. So we'll open that up. And here we go. So now we have Visual Studio Code open. We're going to get to work, and we're going to just import just a few basic libraries. For this, we're going to be using hashlib for generating hash values and pickle for storage, and of course OS for the operating system functionality. So we'll import hashlib, pickle. Okay, so now we'll create an init function that creates a directory to hold our snapshots. So each snapshot that we produce going forward will be stored in a subdirectory in this directory named after its hash. So we'll create this function. We'll call it init VCS. It won't take any arguments. And then we'll use the os makeDirs function, and we'll call it VCS storage. And then we'll use the exists OK equals true flag to make sure that it doesn't raise any errors if the directory exists. And then we'll just do a little print statement. Okay. Next, we'll create our snapshot function. This function is one of two main functions that we'll create, and it will walk through a directory, read each file, and calculate a unique hash. It will then store the files in the file contents in a snapshot identified by that hash. And we're storing the files in a list so that they can be used later during the revert process. We'll create a revert function, which will basically determine which files should exist based on the desired hash. So let's create this function now. We'll call it snapshot, cleverly named. And then we'll input a directory for the argument. So we'll first initialize a hash object to compute the snapshot's unique hash, and we'll use SHA-256, which I'll explain in a bit, but that will be stored in this variable, snapshot hash. And then what we're going to do is prepare a directory to hold the snapshot data, including a subdirectory for the file contents. So we'll just create a dictionary for that. Files and the key. There we go. Okay, so now we're going to walk through the directory, capturing the directory tree and files. So we'll do this in a for loop. So for root dirs files in os.walk directory for files, for file in files. What we're going to do, we'll skip the files within the VCS storage directory to avoid self-referencing. So we'll do that first. VCS storage path dot join root file, and we'll continue because we want to just ignore that. Okay, so next we'll construct the full path to the file. Put that in the file path object. Root file. And then we'll open and read the file's contents in binary mode. With open, so we'll use the with open function. We'll do read bytes, RB for read bytes, as f. Content is the variable that will store the file's contents. And then we're going to update the snapshot's hash with the file content. So snapshot hash dot update content. So we can use that function from hashlib. Next, we'll store the file content in the snapshot data. Files, file path. Okay. So in the snapshot data dictionary, we're in the files key, we're going to store the file path and the content, so that we can have that all stored. So now we're going to finalize the hash calculation for the snapshot. So we'll do that by creating hash digest snapshot hash dot hex digest. So we'll finalize that this way using that function. And then we'll save the list of files that we collected in the snapshot for later reference. So as I mentioned, we'll use this later on in the revert function. So snapshot data file list. We'll access that, and then we'll snapshot data files dot keys. So we'll use the keys there to grab all those file names. Okay. So next, we'll serialize and save the snapshot data to a file named after the snapshots hash, and we're going to use this. We're going to use the pickle module to do this. And then we'll reference the hash digest. Oops. And then we'll do write bytes as f, and then we'll do pickle.dump snapshot data into the file. And that, I believe, completes our snapshot function. And we'll just add probably nice to add a nice little print statement to confirm and print out the hash. So we'll do that. Snapshot, we'll say snapshot created with hash, excuse me, hash digest. Okay. Moving on. Okay, so before we move on to the next function, I wanted to make a quick comment on hashing. So a hash function is a function that takes in input data of any size and produces a fixed size string, often in hexadecimal format. So this string or hash, it's unique to the data. So if the data changes even slightly, the hash changes significantly. In this case, we're using the SHA-256 algorithm. It's very common. It's a member of the SHA-2 family, and it's well known for security, and it's widely used in a variety of applications. So SHA-256, it produces a 256-bit hash value, making it nearly impossible to find two different inputs that produce the same output hash. So it's commonly used, and that's what we're using in this case, and it comes prepackaged in the hashlib built-in Python module library. Okay, so now we'll write the next function. This function will restore the file contents based on the specified hash value. So it will first restore the contents of the files listed in the snapshot, then it will calculate which files are present in the current directory but not in the snapshot, and then it will remove them. So this function will be called revert to snapshot, and we'll provide it with a hash digest. So we'll construct the path to the snapshot file based on its hash. And we'll, of course, use that path, VCS storage, the path to the hash digest, that is, hash digest. And we'll store that in snapshot path. And so we'll check if the snapshot exists, and if not, we'll print a message and exit the function. Just to add failsafe in case we're giving a snapshot that doesn't exist. And we'll return out of that. Okay, now we'll load the snapshot data from the file. So with, assuming that the snapshot exists, that is, with open snapshot path, read bytes as f, we will place that data in a variable called snapshot data. Use pickle to load in the contents into the variable from the file. All right, so now we'll iterate over each file in the snapshot. So we'll do this in a for loop for file path content in snapshot data files items. And we'll ensure the directory for the file exists, creating it if necessary. Make dir, oops, that's not right. Make dirs os.path.dir name file path. Again, exists okay. Always good practice. And we'll write the file content back, restoring it to its original snapshot state. Okay. All right, so now we'll prepare to identify and delete the files not part of the snapshot. So we'll create a set object called current files, and we'll walk through the directory again for root dirs files and os.walk. We'll specify top down equals true. Oh, my keyboard. Okay, and we'll skip the, of course, we'll skip the VCS storage directory. In root, we'll continue. And we'll add each file to the set of the current files. So for file and files, we will add path join root file. There we go. And so now we'll create a set of files that were part of the snapshot. We'll do a set object on the snapshot data file list. File list. And we'll determine which files currently exist but weren't in the snapshot. So we'll call that files to delete. Makes sense. Current files minus snapshot files. Here we go. And now we'll delete each file that should not exist based on the snapshot. So for file path and files to delete os.remove file path. And then we'll do a little print message. Print removed file path. And then once we're done with that, we'll just do a final print statement specifying or confirming that we reverted back to the snapshot. Reverted to snapshot digest. So now we're ready to tie everything together and run this thing. So if dunder name equals dunder main, then we will, so we'll import sys here, and we'll actually extract command line arguments, but we'll just extract the second one. That'll be the one we'll use. sys.argv, grab that. It'll be position 1. And then we'll say if the command equals init, then we'll run the init function. elif, let's just clean this up. Elif command equals snapshot, then we'll run the snapshot of the current directory. So we'll run that snapshot function on dot, which is the current directory. elif command equals revert, then we'll revert to the snapshot, and then we'll grab the next argument. We're going to specify in the command line, if we want to revert, we're going to specify the hash. So we'll grab that. Else print unknown command. And that does it. So we'll go back now to the command line and we'll run this thing, and we'll do an example to test it out. I had to make a few small tweaks because I had some typos, but nothing changed in the logic. And now we're going to run this. So to run this, we're at the command line and we're going to do Python vcs.py. And then we're going to specify the command for the function that we want to run. And since this is the first time that we're running this, we're going to want to initialize. So initialize the directory and create our storage directory. So we'll do init. And there we go, VCS initialized, and we should see a directory here. Yeah, right here, in this top left. So we got a VCS storage directory. So now we could take a snapshot, but first let's create a file, and we'll call this example .txt, and we'll add some text into this. Okay, so if we open the file, we should see, okay, we got a file here and we got hello from the command line. All right, so now we'll take our snapshot, and this should hopefully store everything, all the file and file contents into a unique hash. So we'll do Python vcs .py, and we'll do snapshot. Okay, boom. All right, there we go. We created it with this unique hash right here. Excuse me. Let's copy this. All right, we can even see it here in the directory. We've got this unique hash. So what we're going to do now is now we've taken the snapshot, we're going to want to revert back. But let's make a change first before we do that. So let's just say hello from Visual Studio Code, and we'll save that. And what we'll do now is do a new snapshot. So storing with the changes. Snapshot. Okay, it created a new hash for us. And now, so nothing should have changed, of course. We didn't do anything. So we've got this hello for Visual Studio Code, but we're going to revert back to the previous state. So we'll do Python vcs.py, and we'll specify revert. And when we specify the revert function, remember we need to provide an argument, and that argument is the hash. So we'll copy the original hash from above, and there we go, reverted back to the original snapshot. So let's just double check. Open it up, and there we go. Hello from the command line, and example.txt. So very cool. This is kind of like a Git-like functionality, and we can even, let's just maybe we just do one more. So let's delete the file. Let's just delete. Okay, let's do a snapshot again. Actually, let's copy this. Let's copy this again. So Python vcs.py. We'll do a snapshot now that we've deleted everything. Deleted the example file. Okay, created a new snapshot, and now we'll revert back to the previous snapshot. So Python vcs.py revert. vcs.py revert, and we'll specify that original hash, and then boom, revert it back. So let's see if the file's there. There it is. Very cool. Hello from the command line. Okay, and there you have it, guys. Very simple but functional version control system in Python. So similar to Git, but of course drastically simplified, just the bare bones of snapshots and reversions. So while it's a basic implementation, it lays the groundwork for kind of understanding more complex systems like Git. So experiment with it. Consider adding more features like diff viewing, branch management, and have fun. And thanks for watching. I will provide this code in the GitHub and put the link to it in the video. And if you enjoyed this, please consider subscribing and liking the videos. It would really help me out. And leave a comment and let me know what you want to see next. And if you enjoyed this, thank you guys so much for watching. Take care. Cheers.